Hi. So, you have learned some SQL and now you wish to improve your skills. Thankfully, we have SQL 50 on LeetCode. And if we look at it, the simple description is crack SQL interview in 50 questions. Let's begin. Let me set this to default. And let's go over the problem. 1757. Recyclable and low-fat products. We are given a table called products, which has three columns, also called attributes. A product ID, which can only be an integer. Low fat, which is an enumeration attribute, which means that it can take a series of values provided in a tuple. And if we look down here, low fat, low fat is an enumerable category of type yes or no. We next have the last attribute called recyclable, which is also an enumerable column, and it too can only take one of two values, that being yes or no, signified by y and n. So we have a table, three attributes, product ID, low fat, recyclable. So it's a table that identifies through the primary key a product, its associated ID, and whether it is low fat and recyclable. We have to write a solution to find the IDs of products that are both low fat and recyclable. And we can return the result table in any order. And if we scroll to the bottom, we have the result format. Notice we have products and then we have the output. If we look at product ID 1 and we look back at our products table, we see that it is yes, both low fat and recyclable. If we look at 3, it too is low fat and recyclable. So how do we go about building our solution query? So first of all, we know that we need to select from the table, and it tells us only the ID, so product ID, obviously from the products table, because right now there is no other table that has the necessary information that we need. And if we were to just do this and run our query, notice we get back the wrong answer. What we get back is 0, 1, 2, 3, 4, which is just the product IDs from the product table. But what the solution says is, yes, grab the product ID from the products table, but only consider those where the low fats is yes and recyclable is yes. So we need to condition our select query. And we do this using the where statement, the where clause, I should say. So where low fats is equal to, and here we can directly set it to the value in the enumeration tuple. In this case, yes. And I'll actually leave that for now. And let's run it again. Again, we have a wrong answer. You notice we get back 0, 1, 3. Let's look at our table. 0. 0 is low fat, but it's not recyclable. Well, what about 1? 1 is low fat and recyclable. Well, we also have 3. Let's look at 3. 3 is also low fat and recyclable. So all we have to do within our condition is add and say recyclable is equal to yes. And now if you run this, oh god, I need to sneeze. My bad. All right, and there we go. We have our successful case. We get back the required output 1 and 3. If we now submit by pressing Control Enter or using the user interface and clicking the submit button, we get back a successful condition. Great. So this was the first question, quite simple. All we had to do was select an attribute, which is also a column from our table, and we had to filter it down to only where it is low fats and recyclable are both yes. Let's go to the next question. All right, and I'll again set to default. Question 584, find customer referee. Yeah, that's referee. Referee. Let's use that. Referee. We have a table called customer. We have three attributes, which again is also known as a column. The attribute ID is only an integer. The attribute name is a variable char, which is just simply a string. Next, we have a referee ID, which is an integer. We are also given that the ID is a primary key column for this table. So ID uniquely identifies all the rows within this table. Each row of this table indicates the ID of a customer, their name, and the ID of the customer who referred them. So basically, you go to some store, but you are referred to that store by your friend. Your referee ID will be your friend's ID. We need to find the name of the customers. No, my mistake. We need to find the names of customers that were not referred by the customer with ID equal to 2. So first off, we know that we have to select name from the table customer, right? And obviously, if we just do this and we try running, we should just get back all the names from here. And that's exactly what we get. We get back all the names, but that's not what we want. We want to filter down this query or the solution to only the name of the customers who are not referred by the customer with ID of 2. And let's come to the bottom and look at it. Notice, we have someone with an ID of 1, their name Will, and their referee ID of null. What this means is the person Will is uniquely identified by the ID of 1, and they have not been referred by anyone. Let's look at Jane. Jane has the name Jane, the ID of 2, and again a referee ID of null. So Jane also was not referred by anyone. What about Alex? Alex's name again is obviously Alex, an ID of 3, and a referee ID of 2. This means that Alex, if we look at the referee ID, has been referred to by Jane. And that's how it works. We have a person, we have their associated ID, and we have their referee ID if they have been referred to by someone else. Let's do this. Select name from customer where referee, let's see, referee ID is not null. Let's see if that works. All right, we get back Alex, Zach, and Mark. Because again, Alex, Zach, and Mark all have a referee ID. So now you see that again, we can access the referee ID in some way. But that's not what we want to do. We want to do it where referee ID is not equal to 2 as stated in the requirements up here. That's what we want to do, right? And if we run this, we should get the correct output. But again, we fail. Why is that? We get back Zach. Let's look in the table. Let's look at Zach. Zach is name here, ID 5, and referee ID 1. Well, that's true. Zach has not been referred by the person with an ID of 2. So why is our query wrong? Because you need to consider that if someone does not have a referee ID, then they too meet the condition that states that they are a customer who has not been referred to by someone with the ID of 2. So therefore, when we come here, not equal to 2, or referee ID is null. And we have our next solution, and it works out. So let's see. Now all we have to do is submit, which again, do Control Enter or just use the user interface and click the submit button. And there we go. Wonder what the best one looks like. Let's see. Select name from customer where referee ID is null or referee ID is not equal to. Okay, basically the exact same thing we did, but I assume the order of statements make a difference, and that's why they have much better time. But same thing. Right. So let's think about what we did. We knew that we only had to select the name from the table. We then had to filter it down and say that only select the name from the customer table where the referee ID is not equal to 2. But remember, if someone does not have a referee ID, it meets the condition that their ID is not equal to 2. And that is why we include this part right here. Let's go to the next. I'll again say to default. We have a table called world. It has 5 attributes or 5 columns. Name is a variable char, which means it is a string of variable length. Continent is also a variable char, which means it is a string of variable length. We next have area, which is an integer, population, which is also an integer, and GDP, which is a big integer, which just means that it can hold a much larger value as opposed to integer. We are also given that name is a primary key for this table. Each row of this table gives information about the name of a country, the continent to which the country belongs, its associated area, its population, and its gross domestic product value. And then we have a little more information. We can say that a country is big if and only if it has an area of at least 3 million, which is 300,000 kilometers squared. That's 300,000, right? 300, 3,000, 30,000, 30, 300, 3,000, 30,000, 300,000, 3 million kilometers squared, or at least a population of 25 million. And we have to write a solution to find the name, population, and area of the big countries. And we can return the table in any order. And then we have the format of the table. So here we have the world table, we have 5 countries, and we have the associated row values. And then we have the output. We have Afghanistan. Let's look at it in the table. Well, let's see. It has a population area, so it does not meet the area, but it does have a large population. Therefore, it's a big country. Next, we have Algeria. Algeria, it is here. It has a big area, but what is important is it also has a large population. And that is why these two countries are big countries, and that is why they are in the output table. So let's do that. Let's select the name, population, and area from obviously the country table. I mean the table called country. Is it called country? Wait. Called world. Right. Called world. Let's just do that. If we run this query, we get back the names, population, area of all the data within our table. But that's not what we want. Yes, we want the name, population, area, but we want to filter it. We only want it where the area is greater than or equal to 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. So yes, the area, or where the population, that's spelled wrong, population is greater than or equal to 25 million. So that's 1, 2, 3, 4, 5, 6. And if we run this, that's great, but I hate how this looks. Much better. So there we go, it works, and let's submit that. And we get an accepted output. There we go. Let's look at the best one. Select name, population, area from world area. Exact same thing we did on one line. There we go. And that's the successful submission. This one was very straightforward. It says select 3 attributes from the table, but only select them where the area is greater than or population is greater than or equal to. And remember how OR works. If I have 101 and 111, and if I use OR, what happens is 1 matches with 1 are both true. I mean, yeah, let's start here. 1 matches, 1 is compared with 1. Are either of them true? Yes. 0 and 1. Are either of them true? Yes. 1 and 1. Again, there we go. And that is how OR works in the binary. Let's go to the next question. Okay, let's do this as our last one for today. Set it to default. We have a table called views. We have 4 attributes, also called columns, an article ID, an author ID, and a viewer ID, or all of type integer. And then we have a view date, which is of type date. We notice there is no primary key, which means there is no attribute in this table with unique values. It even tells you the table may have duplicate values. Each row of this table indicates that some viewer viewed an article written by some author on some date. Note, if we have an author ID equal to a viewer ID, it indicates the same person. And what we are being asked is, go find people who write their own articles and read it themselves. That is why it's been asked of you. Write a solution to find all authors who at least viewed one of their own articles once. We have to return the table sorted by ID in ascending order. So we have to do a select. We know what we are selecting. We are selecting the author ID from the views table. And if we just do this, notice we get it wrong. We only get back the author ID, which is the values in the second column right here. That's what we're getting. But what the query states is you have to filter it such that the author ID, that's spelled wrong, the author ID is equal to the viewer ID. Because as we said, if someone viewed their own work, then their IDs will be the same. An example of this is, let's see. Here, look at this one. Row 3, we have an article ID of 2, an author ID of 7, and a viewer ID of 7. Which means that the person who wrote it is person with the author ID of 2, and the person who viewed it has the author ID of 7. What did I say 2? 7 and 7. This is what we are looking for. This is the matches that we need. So where author ID is equal to viewer ID, but we have to order it by author ID. There's no need for us to say ascending or descending because ascending is the default. We come down here and we get 447. It's wrong. Simply because even though our query is right, there's a few things that we aren't doing. First off, we don't want the output column as author ID. We need it as just ID. But it's called author ID in the table views. How do we change that? Within our query, remember, queries return a table. All we have to do is say as, and then pass in an alias, in this case just ID. And now if we run it, we get 447. Our column names match, but the values within them do not match. We require 47, but we have 447. we have redundant data in our solution table. So how can we get rid of the additional 4 in the table? If we wrap our query within a distinct function, so distinct author ID, and we run it again, distinct removes all copies. There we go. So we only have 47 instead of 447. And once we submit this, we get back a successful query. Let's look at the best one and see what we did. Group by author ID. Oh, okay, so they chose to opt out using the distinct order by ID. Oh, okay, I see what you did there. And that was all for today. We'll go over more at a later point.